Okay, those of you that may have already started to take a look at this lesson and maybe start looking at the problems in the textbook realize this lesson is wildly straightforward. Once again, let's put the phones away. The formula is right there given to you because it's not quite as intuitive as you might think, so I just wanted to give you the formula. It's not the 1/2 that you might think it is, it's 1/3. Okay, but it's the same basic idea. You're finding the area of the base, multiplying it by the height, and because it's not a prism and it's not a cylinder and it only has one base, we're taking 1/3 of this now. Once again, I can't stress to you enough the difference between the lateral height that we were using before break in order to find the surface area and the how tall is it height that we use when we're finding volume. Okay, so make sure that they're giving you the appropriate height, just like you did before break when we were doing surface area. All right, so in problem 1, we are being asked for the volume of the pyramid. Same strategy I always want you to employ. Looking at this figure and looking at your formula, did they give you everything you needed? Yes or no? Yeah, they gave us the appropriate height. They gave us the length and the size of the bases. They gave us everything we need. So volume equals 1/3 times capital B times H. In this problem, my capital B is the area of a square, which is 755.5 squared. Times the height of the pyramid, which is 485. And that's going to be a wildly massive number, as it should be, since it's the volume of a pyramid. Like a Greek pyramid. Yes. Because the area of the capital B is a square. Think about how you find the area of a square. It's length times width. But in a square, the sides are all the same. So 755.5 times 755.5, I'm just taking up the space. All right, 755 times 485 divided by 3. OMG. 9227640. That's about as cubic feet. Yes, ma'am. Once again, realize that the base of the pyramid is a square. How do you find the area of the square? Length times width. Good. Okay, pretty straightforward up here. Good. At this time, if you are watching this video on a computer and able to see annotations, pause so that you can work this problem out and choose your correct answer. Once again, ask yourself the question, did they give you everything they needed to? No, they gave us the wrong height. So just like we did before break when they gave us the how tall is it height and we needed the slant height, you're using Pythagorean theorem once again in order to find the height that you need. So the height that I need is there inside the triangle, and this time the right triangle is a little bit harder to see, but I would hope that you see that the hypotenuse of that right triangle is 15. The bottom leg of it is 9. Do you see the 9? It's half the side of the square. And the height that I need is the one going in the middle. So I have h squared plus 9 squared equals 15 squared. And when all is said and done, h will equal 12. And that was the only piece of the puzzle that I was missing. Now we're ready to plug into 1/3 capital B times h. So 1/3 times 18 squared times 12. And I haven't been asked the question out loud yet, but Sometimes the question is sitting in the brain and it doesn't get asked. Most of you have no problem with 1/2 in a formula because you know you can just use 0.5. 1/3, however, is 0.3 repeating. You can't quite type that into your calculator. It'll still be an approximation. Remember that taking 1/3 of something is the same as dividing it by 3. So you can take the 18 squared times 12 and then divide that value by 3, and we're getting 1296 cubic yards. Yes, ma'am. Okay, then we're good. There's your turn. Please take a moment and work through that within your group. Okay, you're ready to compare your work to mine. And if you have something different than I do, and of course this is cubic meters. Anything I need to discuss on this screen? And it looks like we have from this screen what we need. And it even looks like some of you have already just plowed right on with problem 4. So it's asking first for the answer in terms of pi. So that would be I have 320 pi. And then rounded to the nearest cubic inch. And just in case you hadn't gotten that far and you're just copying answers down, remember, copying a bunch of answers down doesn't mean that you have good notes. Volume is 1/3 pi r squared h. 1/3 times pi times 8 squared times 15 is the math that took place in order to get that 320 pi. Still getting what we need from this screen. And I would guess that a lot of you are agreeing with my statement from yesterday that volume is a lot easier than surface area. We have from this screen what we need. Looking at problem 3, again, my question is, did they give us what we needed? No, they did not. So we have to use Pythagorean's theorem in order to find the how tall is it height that we need in order to find the volume of it. So we're doing 4 squared plus h squared equals 11 squared, and that does not turn into a nice pretty number. We've got 121 minus 16, square of that is 10.2 approximately. And that was the only piece of the puzzle that we were missing. Our volume, 1/3 times pi times 16 times 10.2 now. And that word about is giving you the hint that they do want you to go ahead and evaluate the pi. Yes, ma'am. The radius is 4. In order to find the area of the base, we're taking that 4 and squaring it. Let's backtrack. The formula, remember, is 1/3 pi r squared h. You're good? All right. And I have 172 cubic centimeters. Okay, I have 10.2 times 16 times pi divided by 3. I'm still getting approximately 172.
I got 170.
Okay, once again, when I got my first answer, what did I not do? Clear the calculator. Remember, the fewer times you clear your calculator, the better off you are. Which rounds to 172. Look at on this screen. Still getting?